about like what happens at 0. Is it an undefined point or is it a 0 and which one trumps which? The undefined thing trumps the 0. So it's undefined.
That's what we said.
Yeah, it's not defined. If you get 0 in the denominator, even though you can multiply by 0, it's not working out. So we got no point at 0. It's not going to exist at 0. So we went through the first derivative. We found the critical values of 0 and 1. We made a number line, and we got that this one, although you might think it's a max because it goes from positive to negative, it is not because it's undefined and that overrules it. And at 1 we go from negative to positive, so we do have a min. At the point 1 comma e, when we plug 1 into the original, we get e. Okay. Now we got to take this second derivative. And you just have to try to be smart. Try about...
What's that mean? Smart.
Just kidding. Where are you going? Okay. About what first derivative to use to take the second derivative from. Meaning, like, here's my first derivative. I had, like, doctored it a little bit. I wouldn't use this because it's too complicated. You're going to need product rule and then quotient rule. Back the step previous to that, I had this as a derivative. That's a little bit easier to use. So I'm going to use that to take the second derivative from. So my second derivative, using product rule, is going to be the first term times the derivative of the second. And the derivative of negative 1 over x plus 1 is going to be positive 1 over x squared plus 0. Because the negative 1 over x, it's like negative 1x to the negative first, blah, 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 blah. Calculus magic, and plus the second term times the derivative of the first. And the derivative of the first is e to the 1 over x times the derivative of the 1 over x, which is negative 1 over x squared. Sorry, I didn't make it up. I would factor out an e to the 1 over x first and see what that leaves me with. Okay, because I do have two distinct terms. I've got this and I've got this. And even though I have addition here, I have three things multiplied, so I can take out e to the 1 over x from both things. And I'll be left with 1 over x squared plus negative 1 over x plus 1 times negative 1 over x squared.
This doesn't look like it's getting a lot easier.
I guess I could. Yeah, why not? Let's just make this a little more fun. Let's take a 1 over x squared out too. I'm sorry. Okay. Should have been clairvoyant. Or colored. I don't know how it tells that I do have it.
Where's that white out? Girl.
Oh, you have to, yeah, it's negative.
Wait,
It has,
no,
that's why that's negative.
I know.
You know.
So much.
Well, it's good that you know.
The plus one should be
I know, I'm just trying to decide, do I want to take it out as a negative and then only change that one?
No, leave it in.
Plus one at the right be minus one.
Leave it in, leave it in, leave it in.
Wait, why is that not negative anymore?
Because I'm going to take out a 1 over x squared and I'm not going to take that negative with
So
it.
why is the 1 over x not
So
negative
this one's now positive. Like this is all one big term.
Oh, I see.
If I'm taking the 1 over x squared out and not the negative sign, I've got a negative 1 still here that's got to multiply by those.
I didn't see the plus 1 and the x.
See it?
Negative 1 over x. I didn't see the
Why is it negative 1?
So it's e to the negative 1 over x cubed.
Yeah.
Am I right?
What?
What? No, it's e to the 1 over x.
Yeah, or e to the 1 over x
1 over x.
over x cubed.
That's not a bad second derivative.
No. Yeah, it is.
Is this about the worst it's going to get?
Yeah, it doesn't get much worse than this.
Okay.
Much.
It gets parallelly slightly though, you know.
I am so done with school this week. Like, all I can think about is my trip.
Is what?
It's my trip. Just going to
I'm so sorry. You get to go won a trip, okay? It's awesome. I'm so happy for you. Okay, so what are the quote critical values that come from this?
Zero.
Just zero. Zero makes it undefined and it makes it zero. We already know zero is a problem anyway, but that's the only place we're gonna have to test. Do you get the big picture here that like the only places that the original function can change concavity is where the second derivative is zero or undefined. So if I only get one spot that makes the second derivative zero or undefined, the concavity can only change at that spot. So it's going to be like concave up all the way till zero or down, and then after zero it's going to be all one or the other. And there'll be no other spot. So like it's kind of a big deal.
I'm kind of a big deal.
Kind of a big deal. Shut up. Alright, this is a time where I wouldn't make a separate number line. See how nice and easy this is? If I
Thanks.
all I have to worry about with the second derivative changing is at zero. So I can go put a y double prime and use the same number line and test around zero. So that way when I graph, I can kind of look at my one big chart and not have to refer to two different things. So when x is negative, what's the second derivative, positive or negative?
Negative.
Negative. When x is negative, the second derivative is negative. So minus. When x is positive, the second derivative is
Positive.
positive. And always, so like I can put two pluses if that would make you feel happy because I have another partition there. So it tells me that the regular function is concave down to the left of zero, and it's concave up to the right of zero.
So what's this gonna look like?
That's what we're going to do next. Watch it. So exciting.
This problem is going to be a full piece.
It's gonna be pretty gross, isn't it?
Okay, so like I said, I would just try to put my points on that I know. But what really stinks is I don't really know much. I only know 1, comma, e is like here. It doesn't really help me that zero at all. I'm trying to think. How do I know if it's an asymptote or a hole? I don't think it's an asymptote, and I think it's a hole. But I don't know why I think that.
It is an asymptote.
Are you sure? Did you graph it?
Yeah, we looked at it yesterday.
I don't know.
It is.
Are you in radians or degrees?
Yeah, it doesn't matter.
I know. It's a joke.
Well, let me just. Okay, I'm not gonna listen to you for a second.
Yeah.
It's awful.
And then you just
Two boomerangs.
scribble.
Only one of them was just a line.
What if I plug in just to get myself a point?
It was a line.
Wait, hold on. I'm just gonna plug something in. What if I plug in -1/2?
This is what I said.
All the things.
Plug in numbers.
Plug in all the things.
So now that we know this
Well,
It's already got that
Something nice.
it can't hit zero, which
it can hit zero and stop at a hole.
because it's concave up, it can't.
Yeah, but so let's go to the right hand side.
Undivided zero, does that mean there's an asymptote there?
That's what we're trying to figure out.
how are going to be increasing.
Well, let's just look. Okay, so fine.
Yeah, I'm
From 1 on, it's increasing as concave up, so we know that we're going like this. And we know that from here to here, it's decreasing as still concave up, so I'm going like this. So I guess we are thinking it's probably an asymptote, huh? Alright, alright. But then what about the left-hand side? If we are increasing and we're concave down,
Whoa.
You're way off.
Steve, let me say.
I'm so confused.
It's an end behavior asymptote.
I'm gonna look at it. Hold on.
What?
It looks like an end behavior asymptote.
Wow. That is
It's
weird.
an asymptote hole.
I'm increasing and concave down. I need a
Line and then boomerang.
Sorry?
Yeah, we wouldn't get this one.
It's not a line. It's just look.
This is that question on the test that you really don't get.
Pretty sure that's
No, listen, stop. We're
Pretty sure
good.
that's a lie.
We're not wrong. The only thing that we're having trouble
Pretty
with,
sure that's a lie.
guys, stop. The only thing we're having trouble with is figuring out what this left-hand side looks like, because I don't have any points, so it's making it really complicated. If I can get myself at least 1 point, like if I plug in -1/2 for x, I would get, what, -1/2 times e to the second? Is that right?
E to the negative second.
E to the -2nd, sorry, so -1/2 e squared.
So it's like
So it's going to be something small,
two-ish.
right?
And we don't have a calculator.
And third quadrant.
It's going to be something small, and it's going to be something negative. So it's going to be something around here. So I have like a point around here. Well, if it's increasing and concave down, I'm increasing and I'm concave down. And I'm going to make an assumption right now that this is coming to 0, because I'm thinking that it's going to. Like if I have a point at -1/2, -1/2e to the second, so that's like -1/10 is tiny. If I plugged in a couple more points, I'm going to see that these are tiny points. They're negative and they're really small. So this is leading me to believe that this is coming to 0. This is where if we could take the limit of this, it would be helpful, because the limit from the left would help us, but without graphing it, I don't know what the limit from the left is going to be. So this is our best estimate of what this curve looks like, and I think it's basically right. Steve showed me what his looks like. It looks like that. You're only looking at -10 to 10 on your thing, so it's kind of hard to see that this is actually a curve, not a line. It's definitely not linear. Okay, if it was linear, it couldn't be concave down. Lines don't have concavity, so it's not a line. It's a curve. It's concave down, and it's increasing. So it looks like that. This would be really hard to come up with on your own, again, because of just the ambiguity of not knowing where that point is. That whole
So it's
solution.
gonna be our test.
I wouldn't put one like this on your task, because there's just too much to work through, but it's not a bad problem. That is what it looks like. It looks like I have an end behavior asymptote here of some sort when I looked at the graph. I wouldn't know that from that. I wouldn't know what the heck that looked like, and you shouldn't know what it looks like.
Just go to another calc class if you do.
Let's do another one that doesn't have as much ambiguity.
What are we going to
Okay, let's do another one. And it won't be so
Concave up
silly.
if the second derivative is positive. Concave down is negative.
Like x squared.
Concave down. Brown.
Concave down is brown.
Okay.
How's your point on the asymptote? If that's open.
You can have that. I mean, that asymptote's only counting for the one side, and it's open, so it's not like actually defined there. So it's not really a point on the
How's
asymptote.
the asymptote only counting for that count?
Well, like it's an asymptote just talks about like end behavior in a way, like what is a graph tending towards as x gets closer and closer to 0 from the right, we're getting closer to that asymptote. It doesn't mean I can't have another part of the graph that comes up to it. I can never have an x value on it that's equal to any y value there, but I can have something come in like that. It's probably the weirdest thing graph you'll ever see, so don't stress too much about that. This one is one you could be tested on, because this one's actually not that hard.
Real.
You sure?
Yeah, I'm sure.
Yeah.
I decided I would try this one before class and make sure it worked.
Good.
Alright, so start it and see where you go, and we'll go through it. Why did I just hear a calculator?
You can't use calculators.
Don't do it! Don't do it!
You were doing it. Get off the calculator. Jesus. What are you doing?
Zach,
I need to check something with
What are you doing?
exponents.
okay, Zach, is that getting any of the camera?
Yes.
Okay.
It's done.
Mhm.
When the second derivative equals 0, it's not the point of inflection.
Yes.
Want to say it again? I'm sorry.
When the second derivative equals 0, that's the
It's
point.
only the point of inflection if the concavity does change from positive to negative. if it doesn't change concavity, then it's nothing. Okay?
What am I supposed to do with the second derivative?
You are going to still plug in points to the left and the right of 0 and see if there's positive or negative. What's with the side?
First calculator, no.
That wasn't an intentional sign. It was just a sign. I'm sorry.
Pretty rude.
Why is -1 to the 4/3 -1?
It shouldn't be. Just put -1 in parentheses.
That's why.
So I'm just taking 1 to the 4/3 and making it negative. I didn't make up the rules.
Isn't if x is negative and y second derivative is positive?
This is what I got for my second derivative.
Yeah.
So x to the 4/3 means I'm going to take something to the 4th.
Oh.
So it's going to, no matter what I plug in for x, the x is going to be positive. Seriously?
What's sass? I'm not holding one in this background.
Take the hint. You got stuff plugged in. You got like your own little world back there. Alright, so did you get the same thing for the derivatives that I got?
Yeah.
Okay, so my first derivative, my second one. So this is kind of weird. My first derivative changed from negative to positive, which means I have a min there. And I know it's a min, it's not an undefined point because 0 has no problem in the original function. If I plug 0 into the original, I have a point at 0, 3. So I know it's not an undefined point, it's not an asymptote or anything like that. But what I do know is that this critical value came from the derivative being undefined. It's important to kind of keep that in your mind as you go, because if this was found from the derivative being 0, it's probably smooth. It's nice. It's got a horizontal tangent line. It's smooth. Or it's like this thing, and it's got a horizontal tangent line here. It's not necessarily max or min. If the derivative is undefined, it's a corner or a cusp or an asymptote. We know it's not an asymptote, so it's either a corner or a cusp, or it's a vertical tangent line, depending on what it looks like. So then I test the concavity, and it's negative always, so it's concave down always. So I'll go graph 0, 3. And if to the left of 0, 3, it's supposed to be decreasing and concave down. So look like a frown and decreasing, so I'm like this. And then to the right of it, I'm supposed to now be increasing, but still concave down. So it looks like that.
That's the graph of the original function.
That's the graph of the original function. Now, you got to be kind of careful. Is this ever going to scoop back around and come down?
No.
No, because the derivative is always positive on that side, so the function's always going to be increasing. Otherwise, I would have gotten a max or a min, because it would have come back down, I would have had a maximum value, but I don't. So be careful when you graph it that you're clear that it's going like up forever. There you go. That's okay, right?
Yeah.
Okay, let's do one more.
Oh,
Tab
geez.
do.
We do that.
We played taboo last week.
Yeah, I mean,
You play
we need to do it at least once a week.
sorry, we never got to the homework.
Yeah.
Yeah.
Okay.
You knew that, right? You didn't do any of
Yeah,
the last time.
yeah.
Okay.
There was homework last night?
No, Eric left early and I thought we'd get to it, but then that debacle problem happened and we didn't. Oh, and you know what? It might be helpful to remember what you're supposed to remember about asymptotes. Like horizontal ones in particular. Remember from last year?
Yes.
Not
That
really.
if the degree of the top is bigger than the degree of the bottom, there's like an end behavior asymptote. And if the degree of the bottom is bigger, there's a horizontal asymptote where? At 0. And if the degree is the same, there's an asymptote at the ratio of the coefficients. So this has a horizontal asymptote at 1. Okay, so it's just kind of helpful to know that when you're graphing.
Oh, because that's one over there. Got it.
Just to interject, when I do get something kind of simple for my derivatives, I'm making one number line, you might be noticing. If you don't have something all complicated with like a million critical values, I think it's easier to make one number line. It's easier to graph from that. If it's undefined in the original problem, it's an asymptote. But I was actually about to write point of inflection because it changes concavity, and I was like, oh crap, -8 made that undefined, so I knew it was an asymptote. So do your derivatives match fine?
Yes.
Okay,
Why is
good.
it cubed on the second vertical?
Say it again, and the second one yours is what?
Why is it like 3?
This is the first one.
Yeah.
So I brought it up like this and used power rule. So I did like 2 times this and then this to the 1 minus that. So I got the same critical value for both. So I made one number line. I see that it's increasing all the time because the first derivative is positive all the time. I didn't even have to plug in. I looked at the first derivative and You know, if the top's positive and the bottom's squared, then it's always going to be positive. And then the second one changes from positive to negative. I first thought, oh, point of inflection, because it goes from concave up to concave down, but it doesn't, because it's not a point of inflection. When I go plug -8 into here, I realize, oh yeah, that's right, it's a vertical asymptote at -8.
If I see a problem like this on the test, do I really need to do all this derivative stuff to graph
Yeah,
it?
I wouldn't put one this, quote, easy on a test, because this is something you could have graphed in pre-calc. Okay, this is something we found the asymptotes for, we picked a couple points and we graphed it. So it wouldn't be this, like, easy on the test. So from here, it's increasing in concave up to the left. So it kind of, you know what, like, quadrant it's going to go in because of the way it's going to look. It can't be increasing in concave up and go down here. It's going to cross over everything. So increasing in concave up like that, and then increasing in concave down like that. Yeah, I know. I should have started with this too. Sorry. Whatever. Makes you stronger. Okay. Here's a couple of problems I found from.
Wait, I have a question.
Oh yeah, sorry. Go ahead.
Wait, how do you know there is an asymptote at Y component?
So that's what I said from pre-cal with remembering horizontal asymptote. Sorry. Anyone need that recap again?
Oh, I heard that.
Okay. We don't have to do all these. Oh, I handed someone the ones that were circled in this row. Where do I start at? 5? Oh, no, no, sorry. Just go 6, 7, and 9, 10. Yeah, go 6, 7, 9, 10.
Oh, man.
And tomorrow we'll do some interesting graphs.
And what?
Some interesting graphing problems.
The first one was interesting.
Without quite so much chaos.